Hello and welcome to this Further Maths Core Pure 1 video on complex numbers modulus argument form. So we've got some notes here. We're looking at z being a plus bi. Now if we work out the modulus of z, that gives us a value of r, and the argument of z, that gives us a value of theta. And we could work backwards from that. So here we've got our complex number, and if you look at this, you can see that the x component would be r cos theta, and the y component, so the imaginary component, would be r sine theta. So we could write this number as r multiplied by cos theta plus I sine theta, and that's called the modulus argument form of z, and it's also called the polar form of z. So if we just look at these first four examples, should recognise these as the points we plotted in the previous video. So if we're going to write these in modulus argument form, we're going to write it as r, which for this first one was root 2, and then we have a bracket, cos of its modulus, cos of pi by 4, plus I sine of pi by 4. So that's all you need to know for writing it in modulus argument form to start with. So let's look at the second example. This is going to be 5, because that's the modulus of this, which we found before, brackets, cos of, now this was a negative modulus, so minus 0.927 plus I times the sine of minus 0.927. The third one is root 41, cos of 2.47 plus I times the sine of 2.47. And the last one here is root 13, cos of minus 2.16 plus I times the sine of minus 2.16. Need an extra bracket in somewhere. So that's how you write a number in modulus argument form, and it's useful because it can make certain calculations a lot easier. So what you're told here is that if you've got two numbers written in modulus argument form, then if you want to multiply them together, you multiply the modulus and you add the arguments. If you want to divide them, you divide the moduli of each one, the modulus of each one, and then you subtract their arguments. So let's just see how we work this out. By the way, when you have studied one of the later pure modules, you will be able to prove this using the double angle formulas. But for the moment, just take it on trust that that is the case. So if we look at question 2 here, this is our first complex number. Z is 3 times cos of 5 pi by 12 plus I sine of 5 pi by 12, and that's Z2. So that's the modulus of 4, and the argument is pi by 12. So if I want to work out Z1 multiplied by Z2, I multiply the modulus of each complex number. So 3 times 4 is 12. And then I'm going to add the arguments. So I've got the cos, I've got 5 pi over 12 and pi over 12. So that's going to be 6 pi over 12 plus I sine of 6 pi over 12. And if we work that out, that's 12 times cos of pi by 2 plus I sine of pi by 2. Cos of pi by 2 is 0. Sine of pi by 2 is 1. So this is equal to 12i. That doesn't usually happen. It doesn't usually simplify just to be an imaginary number, but it does show you how useful this form is in terms of multiplying together, because that's a much quicker calculation than it would have been to actually multiply these numbers separately. Let's look at question 3. So question 3 wants you to multiply Z1 which has got a modulus of 2 and an argument of pi by 15. And then Z2. Now, the first thing you should notice about Z2 is that it's not in modulus argument form because of that minus in the middle, and we need to deal with that. So let's just have a little look at Z2 to start with. Z2 is equal to 3 times the cos of 2 pi by 5 minus I sine of 2 pi by 5. We want that to be a plus in the middle, and here we can use a very useful fact about the cos and sine of angles. If I replace the angle with minus the angle, let's see what happens. So, because of the way the cos graph is, cos of minus an angle is the same as cos of plus the angle. So I can replace cos of 2 pi by 5 with cos of minus 2 by 5. Those are exactly the same. Check on your calculator if you don't believe me. Now, what happens if I replace sine of 2 pi by 5 with sine of minus 2 pi by 5? Well, the sine of minus an angle is minus the sine of an angle. Well, that works out in our favour, because what I can do is I can write it like that. So just think about this for a minute. Sine of minus pi by 5. Sine of minus pi by 5 is minus the sine of 2 pi by 5, sorry. So the sine of minus 2 pi by 5 is equal to minus the sine of 2 pi by 5, which is what we want it to be, so that this is the same. So if ever you have a minus in there, you need to do this little maneuver to get it in proper modulus argument form. And you need to look out for that. So we've now got Z2 in modulus argument form. So if I want to work out Z1 multiplied by Z2, I'm going to use this form of Z2, and I'm going to use Z1 here. So multiply the modulus of each one. So that's 2 times 3, that's 6. And it's going to be cos of, so I've got pi by 15 here, plus minus 2 pi by 5, plus I times the sine of exactly the same thing, pi by 15 plus minus 2 pi by 5. So let's see what this works out to be. This is going to be 6 times the cos. Change this all to 15, so I've got pi over 15, take away 6 pi over 15, so that's minus pi by 3 when we work that out. So that's minus pi by 3 plus I times the sine of minus pi by 3. Bracket. And if I wanted to write that back in a plus bi form, then I would use the fact that cos of minus pi by 3 is equal to a half. So 6 multiplied by a half is going to be 3. And the sine of minus pi by 3 is minus root 3 over 2. So multiply that by 6 and I get minus 3 root 3 pi. So either form, modulus argument form or x plus iy form, either form is fine. You need to look at the question and see what you're asked for. So question 4, we're asked to divide. So question 4, we've got to work out Z1 divided by Z2. So Z1 divided by Z2. So we're going to divide the modulus of each one. So I've got root 2, and the modulus of this is 1. And then we're going to subtract the arguments. So it's cos pi by 12 minus 5 pi by 6 plus I times the sine of pi by 12 minus 5 pi by 6. And when we work that out, we get root 2. Work this out. Either do it using fractions or use your calculator. This is cos of minus 3 pi by 4 plus I sine of minus 3 pi by 4. And converting that to x plus iy, we get -1 minus I. So either this form here or the final form there, either of those aren't acceptable answers. You just have to see what the question asks you for.